Awesome. I think we could get started and I'll continue to let folks in as they get here. Welcome, everybody. My name is Itzel Torres. I'm with our Ventura County 3C Run team. Today we have Unitary versus split heat pump water heating systems with Eric Pino from Small Planet Supply. Before we get started, just a little bit about 3C Run for anybody who's new to our network. Next slide, please, Eric. So 3C Run is a Tri-County Regional Energy Network. It's a collaborative partnership between Ventura, Santa Barbara, and San Luis Obispo counties. Our programs were designed to reduce energy use, and our goal is to try and make the Central Coast a little bit more equitable and economically vibrant. Our 3C Run is funded by ratepayer dollars that we pay into the public's good fund that is then channeled through the CPUC. This allows us to bring back money to the region and do trainings like the one we're going to have today. Next slide, please. And these are the three different services that 3C Run offers. We offer incentives for residents and multifamily properties, and also for businesses through our home energy savings program and our commercial energy savings program. And right now, our incentives are open. So if you have any questions about that, feel free to reach out to me and I could walk you a little bit more in depth through that process. And then we have our training bucket, which we offer trainings for building industry professionals that are interested in high performance building or building science in general. And then we have our other program, which is the Energy Code Connect program that covers anything that has to do with the California Energy Code and just helping folks navigate that. And then our last bucket is our technical assistance program, which we have our agriculture energy solutions program, which helps farmers reduce their energy use. And then we have our energy assurance services program that offers energy audits to critical facilities in our area. And with that, I'll hand it over to Eric to get us started today. Thank you, everyone.
Hello, everybody. Oh, still fighting with PowerPoint a little bit. Sorry. Welcome to Unitary versus split heat pump water heaters. I am going to take a break here and there to answer questions, and a lot of folks do ask, is there going to be the slide deck available later? Is there going to be a recording available? Yes. So sometimes it can take a minute to get that out to everybody, but we will have the slide deck out. Um, And so please feel free to ask away if you have any questions. I'll take a break here and there to answer those as we go. Um, and with that, we'll get started. So I know that heat pumps and heat pump water heaters are not really new at this point. They're becoming required in a lot of places in the country, but we still have a lot of sort of institutional inertia, and that results in maybe bad installs, some misapplied technology, unhappy homeowners. And so I'm very happy to be here today to explain kind of the difference in some of the form factors for heat pump water heaters and kind of dispel some of the myths and go over the differences between this, a more conventional, well, historically conventional system, and hopefully help you pick, which one's right for you, which format is right for you, size it right, and install it right so that we don't have any of those sort of horror stories that are lingering around. So first, what is a heat pump water heater? We'll review a little bit of the basic underpinnings of this technology. Why are they different from our older, more conventional systems like gas or electric? And how do we describe their performance? And what difference does a refrigerant make? What even is a refrigerant? So The refrigerant is a working fluid, and it's the underpinning of heat pumps in general, not just for water heating, but for everything. It's also in your refrigerator, as the name might suggest, and a lot of other appliances that we use, the AC in your car. A refrigerant, like I say, is a working fluid, and basically what the work that we have it do is phase change. So going from liquid to gas, gas to liquid. Um, Refrigerants are really good at doing that at low temperatures. We'll get back to that because I know there some of that institutional inertia is around what temperatures do they operate at? Is it too cold here? We'll come back to that. Usually, though, these refrigerants will change to a gas even way down into the negatives Fahrenheit. There's a useful range that might not go down that far, maybe. Um, but generally, the boiling point for a refrigerant's going to be below zero by a fair margin. Um, so the phase change thing may not seem particularly useful, um, but there's two things to maybe remember from physics class here. Pressure is going to change the point at which something changes its phase, and the transition to gaseous form absorbs energy. Likewise, the transition back to liquid form is going to release energy. And so if we manipulate the pressure in a closed system, we can get that heat energy to release or be stored where we want it, assuming we can vary the pressure in that place. And that's how heat pumps work in a nutshell. Specific refrigerants have their own operating parameters, right? They all like different conditions. Um, that could be ambient temperatures, operating pressure, charge needed. They're all a little bit different. Most are incompatible with equipment made for other refrigerants. You can't just drop in 410 to, oh gosh, I don't have an example ready, but you can't drop one refrigerant into another system usually. Usually. A big issue for a while now has been making newer, more environmentally friendly refrigerants that are drop-in replacements for older equipment. That's been driven by something called the Kigali Amendment to the Paris Accords, which is basically a big international agreement saying we're going to try not to destroy the planet as fast as possible. They use a metric called GWP, and so you'll see that a little bit going forward. GWP is global warming potential. And basically, it's a metric that uses carbon dioxide as a reference point. They call carbon dioxide a GWP of 1. And then they use that to communicate roughly how much the manufacture and the use of a refrigerant is going to contribute to climate change relative to something like carbon dioxide. On the note of environmental stuff, the IRA was a pretty big deal, right? Keyword was, which does tend, it's a question that I've gotten lately of, does this have legs? Is this what I should be going with? What's the future here? And without being too opinionated, I guess I would not bet on the federal government driving much of these changes with a focus on GWP going forward. But California has definitely been vocal about this. They remain committed to agreements like this. And I would assume that at least on the West Coast in general, the GWP metric and electrification at large remain relevant. And on the note of longevity, it would also really surprise me if the Feds stopped pursuing electrification altogether. A lot of our domestic policy now heavily assumes energy independence and a level of conservation for purposes of industry that doesn't really exist right now. Isn't possible with the way we do things right now. Maybe short term there will be kind of a punt to gas, but I don't think that can's going to get kicked down the road for very long. I think long term we are going to end up with a diversified energy system, which again takes us back to electrical conservation. And locally to the West Coast, I don't think it's really going to change a whole lot, except maybe for the absence of some federal incentives. Um, the short version is basically whether or not you believe in climate change, heat pumps aren't going anywhere, particularly in the water heating application. At least I don't think so. When we talk about heat pump water heaters generally, usually the units available on the market are going to be using a refrigerant called 134A. That's the more common one. To a lesser extent, something called 410A. And those have been pretty ubiquitous across heat pump equipment for a while now, but both have a pretty high GWP. And in the interim, a lot of manufacturers are going to probably my favorite one because I can remember it 1234YF. And then R32 is also pretty easy to remember. 1234YF is bold here because it's probably going to be our landing place for a while. Generally comparable to 134A, but where 134A has a GWP of like 1400, 1234YF is about 5. So it's compatible with a lot of stuff that's out there. It's got a way lower GWP than targets are going to need to hit for a little bit. I would figure that's probably going to be where we'll end up. There's also 513A, which is a mix of 134 and 1234, coming in at like 630 for GWP. And then I've been hearing a lot about our 32 units in production. 32 is good at higher temperatures, which is pretty nice for us on the consumer end. It's also pretty nice for load shifting purposes. If we can overheat water, we can store it longer and reduce, we can kind of time that to ease the load on the grid. You might be familiar with that CTA 2045 thing. That's kind of what they're trying to do with that. But its GWP is still pretty well beyond the longer term goals of the Kigali Amendment. And I would figure 1234 YF would be our landing place. The phased out refrigerants are still going to be available for maintenance purposes. Again, might be worth looking at something with a little bit newer fluid if you're more than like a year out. 290 is pretty exciting. Works really well. It's widely adopted in Europe. It would be a really cool addition to our lineup here in America. Unfortunately, it's also a mix of propane and other hydrocarbons. And in the US, at least, it's not usable as a refrigerant because they're concerned about flammability. It's worth noting that most refrigerants are either flammable or not very good for you. And historically, we haven't really had an issue with pumping lots of flammable gas inside of our homes, particularly in kitchens. But as it is, not allowed. And I'm dreaming of the day that I say I sell propane and propane accessories one day. CO2 is another one that's mostly used in commercial refrigeration. It requires really, really high pressure. It has some limitations, but it's an outstanding refrigerant and it has a really wide variety of operating temperatures down into well into the negatives. And it happens to be used in one of the only split units that's currently available. So it's kind of a handy one. And again, it's just carbon dioxide, so GWP of 1. They usually get it for medical gas production. Um, it's it's pretty cool stuff. Heat pumps use the pressure change, right? So we'll talk a little bit about operation. We're using that pressure change to force refrigerants to change phase in specific places. That's kind of the magic to this whole thing. For heating, we're going to pull our heat from the outside air. So remember, when we vaporize, we're going to store a little bit of heat. And then we're going to move that superheated gas to a different place in the system where we will then condense it back into the liquid and it'll let go of some of that extra stored heat energy and it'll drop it where we want it. And then we just sort of keep going. And in that way, we can move, kilowatts of heat energy into a building at a fraction of the cost of actually converting electricity into equivalent amounts of heat. And so one of my favorite things about physics is that, physicists record the immutable laws of all existence, and then engineers find the most cost-effective way to lawyer those rules into unrecognizability for the sake of our comfort and convenience. This is basically an exploit in the way that everything works, and the fact that it does work is very satisfying to me. Um, from an end user and a policy perspective, the reason we're looking at heat pumps for water heating specifically, you're probably more familiar with them on the conditioning side, but it's because at a policy level, water heating consumes kind of a ridiculous percentage of the available electricity relative to the use we get out of it. It's not quite a luxury, right? It's definitely we hygiene is important. We do use it in some applications for space heating, which is kind of at that point is kind of a safety thing. Um, but it's definitely also sort of a comfort, and it's one that comes with an energy price tag of 10 to 20% of domestic energy use, right? It's basically it's an easy target for policy looking to reduce our energy consumption. And and those policies, just heads up, are already here. That's that 2045 thing. Um, and then on the consumer end, it's kind of the same deal. I know that the government side really annoys a lot of people. Nobody likes being told what to do. But on the consumer end, it's the same deal, right? Just a different perspective. Cutting 15% off your power bill to still be comfortable is a pretty good deal, even if electricity is cheap where you live. Um, Last of the boring stuff. Thank you for bearing with me. The metrics that we use to measure heat pump water heater performance, these are things you should remember. This comes up a lot. A lot of manufacturers, when you look at their cut sheets for a unit, they're going to be talking about some or all of these. COP is really the one you see the most these days. It's a simple ratio of energy in to heat out. Energy and heat can both be expressed in kilowatts, and that's what's happening with COP. An electric resistance water heater has a COP of about 1. You put in 1 kilowatt of electrical energy, and you get about 1 kilowatt of heat energy out of it. Gas has a COP of less than 1 because it's a combustion appliance. You have to vent the combustion gases out, and you're always going to lose a little bit of heat that way. Those are getting pretty efficient, but they're still always going to be less than 1. And then when we look at heat pumps, heat pump water heaters specifically, normally, at least at our normal ambient temps for most of the West Coast, you're going to be somewhere around a COP of 3, oftentimes much higher than that. It is relative to the ambient temperature, but uh, functionally, you can kind of think of it as like 3-ish times as efficient as an electric water heater. Some you'll see less commonly are SCOP, SCOP, which is COP averaged across a heating season for kind of a realistic worst case picture of your performance, right? So that one is weighted to account for, maybe it gets really cold in the winter. SCOP is mostly used in metric countries, right? Europe a lot of the time. It's really more common in mini splits and conditioning systems, but you see it on a water heater every once in a while. Um, HSPF is the American version of SCOP. It's the one you're going to see a lot more, and it can be found with a little bit of effort because it uses BTUs, and this is America, right? The main idea is that big number good, and when you convert from SCOP to HSPF, your number is going to get bigger. That's just because of the unit change. Um, UEF is kind of the SEER rating of heat pump water heaters. I don't love it. It's not super useful except for kind of comparing two systems in a vacuum, where again, big number good. But it is what most rebates and government programs are going to use for whatever reason. Although again, federal level stuff, I don't know. But locally, this is what most utility providers are going to look at. And because it's a qualifier, just about everything is going to have that readily available. Okay, so that was the last of the boring stuff. Sorry about that. On to our two form factors. So when we talk about a split system and a unitary system, we are talking mostly about where the compressor or the heat pump is going to be located relative to the tank. So a unitary system has the heat pump built into the tank generally. Typically, those systems are going to be a little more comfortable to look at for people who are used to something like an electric storage water heater or like a gas water heater. It's just the one package. You put it where your water heater goes. They work in sometimes similar ways with the addition of the heat pump and kind of some caveats around how those operate. They're laid out in a similar way. And really the difference is going to be just the weird fan thingy on the top. We call them unitary systems because they're a unitary package. Split systems then are exactly what you would expect them to be. Um, what you might not expect is that the Senko, which was the one that was the only one available on the market for a long time, has a little anime guy. Um, but oh, sorry. So with split systems, though, the heat pump is going to be separate from the tank. Normally, we put it outside. Now, I do try to be as brand neutral as I can when I do these presentations, because we do carry some of this stuff. The Senkos specifically are something we've carried for a really long time. Um, there is kind of limited availability on the market of split systems. There's two that I know for sure are available right now. I had heard of potentially a third one. Um, for the purposes of this, a lot of this information is going to be specific to the Senko 2, but we do have a whopping 2 units now readily available on the market. And so I'll talk a little bit about that. But again, most of my experience is going to be with the Senko. They have similar-ish operations. So we'll talk a little bit about both when we get there. But just be aware that the range of products available for split systems is a fair bit more limited. All right. And so right out of the gate, now that we're done with our metrics, let's talk about the herd at this point of elephants in the room. Unitary systems really got the brunt of this, and I'm guilty of saying stuff like this myself. Um, but there are some statements that you hear every single time that you mention heat pump water heaters anywhere some guy with an opinion can hear you, right? They're loud, they make your house cold, they're slow, they make my heating bill go up, you can't fix them. Um, and so those things are rooted in truth, I guess, but it's not different from any other technology, right? So when I was growing up, we had, it was like a 2001 Toyota Corolla, right? It got less than 20 miles per gallon, right? If somebody tried to sell you a new subcompact commuter car today that got 20 miles to the gallon, you'd lose your mind. Um, these are just things to consider or these are things to consider with heat pump water heaters, but they're mitigated much, much better now that technology is progressing and manufacturing is scaling up. The manufacturers are iteratively improving every model they produce, and the limitations that we had with some of the older systems that were available on the market are shrinking every year, and in most cases have kind of become non-issues. You need to look at the documentation for the model you pick, right? You need to make sure that it's going to get installed correctly because just between you and me, that was the source of most of those issues, most of the horror stories where they weren't installed correctly. Um, but for the most part, what you're looking at there is how much air do I need, right? They'll tell you you need 700 cubic feet or something like that. And the noise level that the compressor is going to produce. Those are really the two. We'll get back to sizing in a little bit, but those are the two things that you really want to look at is how loud is it going to be and how much air do I have to feed it. Again, when we hear those real horror stories about a heat pump water heater, those are design problems and they're install problems. It's the same thing as mini splits, right? Mini splits are super common now. They're almost everywhere. But back in the day, we had all these horror stories, right? You can't just slap a heat pump in where a gas system was, size it just like you size the gas system and expect it to work. We need to approach the install thoughtfully. We need to be mindful of how the heat pump's going to operate. And if your install is good and you sized it right and you have enough air, the end user will have a good experience. So let's talk a little bit about the considerations that we do have with the unitaries with those things in mind. So unitary systems, despite what you may have heard, have a lot of advantages, right? They're readily available. They have a lot of big name brands producing a wide variety of systems, and that's really a nice thing to have in your pocket when you're looking at a system. There's a lot of units out there. Some are kind of low end, some are high end. Things like noise, recharge rate, output temps vary a lot between them. Um, Even at the higher end, unitary systems aren't super expensive. Definitely more than like an electric unit or a gas unit. But unlike gas and electric, they have a lot of rebate programs to help locally, at least, maybe not federally anymore. And because they have a COP greater than one, they're effectively they have a payback period, right? And I'll go back to the car analogy for a second. So I drove a Honda Pilot for a long time. I got like 18 miles to the gallon. I did the math on what I spent to feed it for a month and realized I could basically negate the payment of an electric vehicle with what I was spending in gas. So now I drive an EV, and I've had to make a couple of adjustments in the way I drive and how I think about my vehicle, but I do love it, and it's costing me less than the Pilot did to own. This is the case for heat pump water heaters as well, just on kind of a smaller scale. In aggregate, they save you money, even if upfront cost of equipment is a little bit higher. Installation, of course, can make that a little bit of a different story. I don't want to be unrealistic. It's an unfortunate truth that basic services like installation have gotten surprisingly expensive very quickly over the last few years. But as installers get a little bit more comfortable with the technology, as there gets to be a little bit more competition in that market, and it already kind of seems like this is happening, those install costs are going to go down. This is not bleeding edge anymore. I can't tell you specifically what that would cost. Call around for some bids. Um, but I think in aggregate, these end up saving you money. The biggest advantage that unitary systems have over a split is going to be that availability and that diversity. So there is a unitary for everyone, right? They can be big, they can be small, they can be slow and really hyper prioritize your energy savings. They can be really fast and very comfortable replacements for systems people are used to, like electric. Um, and they're usually programmable, so you can actually kind of pick what you want to do. If you have a time period where you want to save energy, you can program it and say, hey, only use your heat pump, only work when conditions are ideal. If you have 10 people over for holidays or whatever, you can say, hey, I don't really care how efficient you are. Make as much hot water as you can because people are going to want showers. So that's another advantage they have over some of the more conventional systems is that usually the unitaries at least are pretty programmable. And a lot of them have like phone applications built in, so you can do monitoring or change your settings from your phone. And some of them, like this one, are even kind of cool looking, which is a weird thing to say about a water heater, but they are. Generally speaking, all the unitary systems are either on board with or at least have the option to be on board with CTA 2045. And that's a demand response measure that specifically California, but also utility providers kind of all over the country are trying to adopt. And basically, it's a measure that allows your utility provider to either trigger or block out water heater operation depending on the power availability. Um, Again, that one's a little divisive. Some folks really like it. Some people really don't. Um, Most unitary systems are going to have electric backup elements built into the tank. Um, and so that also kind of complicates it. Maybe they have like your elements go on, maybe they just have your heat pump go on. It can be annoying to have your utility provider governing how your house works, but overall I'm in favor of this, right? So I am who everyone calls to complain. And most of the complaints I get from homeowners are about having to adjust their behavior for a piece of technology that behaves differently than what they're used to. Electric elements are kind of our training wheels for electrification, or the parachute, maybe depending on how you look at it. Um, we still will get our primary operation from the heat pump, but when the heat pump can't operate due to the temperature or it can't keep up with our demand, we have those backup elements in there. Um, and so they're going to act a little bit more like a water heater we're familiar with, and help us bridge that gap. And yes, using them is going to increase your power use a little bit, but not to the extent that it's not still at least 2 or 3 times as efficient overall. And most importantly, which is this is sometimes forgotten by us building science types, is it's your house, right? If you want to use your electric elements, if you want it to go faster, then use your elements. Let's see. Gonna take a quick look. I've seen a couple of messages come through. Okay, no questions so far. So unitary operation, to expand a little bit on those backup elements, by default, most unitary systems are going to be ready to go out of the box in a way that meets your efficiency and your comfort kind of in the middle. We can prioritize one over the other pretty easily with just some programming steps. But automatically, the unit is going to use the heat pump wherever it can. And if that's all it needs to meet demand, that's all it's going to use. But if we have a high flow fixture or a period of high demand and the unit realizes that the heat pump isn't keeping up, it'll kick on the element, right? And I say element, usually there's going to be two. I have a little typo on here, but it's only going to use one at a time. And all electric water heaters do that, right? The unitary systems, I guess what I'm trying to stress here is the unitaries are really trying to mimic an electric water heater as much as they can and be a lot more comfortable for people who are used to those systems. They are just going to prioritize energy savings as much as they can uh, when they can. So I mentioned airflow requirements. Okay, let's talk about some of the challenges with a unitary system. I will probably be talking about this forever. Unitary systems have space requirements, just like every other tank. But the big difference with the heat pump based systems is that we need to feed the heat pump with air. Typically, you're going to need about 700 cubic feet, right? Not square feet, not square feet. Cubic feet's a lot easier. It's like a 10 by 10 by 7 room. Um, Most rooms have higher ceilings also, so you can usually get a slightly smaller footprint for the room that the water heater is in. Some units need less, some units need more. 700 is kind of the average. Um, but if we have space limitations where that's not going to work out, there are a couple of things we can do, right? I don't have a 10 by 10 by 7 closet somewhere to put a water heater in. Um, Louvered doors are one option where maybe you do have a closet that the tank will fit in, but it's got a door on it. If you can get enough, they call it net free area, so basically just how much air can be pulled through the door. If you can get enough net free area on the louvers in a door, right, basically kind of like a screen almost, that can be sufficient, right? You can get it into a closet as long as you have enough space for things like condensate um, and exhaust. You can use a louvered door to allow for the airflow. And you can see bottom bottom left picture here is one of those doors. They've got some grates in it, and that's how they're getting air fed into the heat pump. Our other option is to duct to the outside. And that's seen in our top picture here. This does have a little bit of an efficiency penalty, but it's not really enough to worry about. We can also duct our feed air to the outside. I tend to get a little bit wary of that, although I am definitely in a heating climate. It gets cold here. I'm in Washington State. It's been, 30 degrees for the last week. I know a lot of places have been colder, but um that's usually a little bit lower than a unitary system's going to want to run at. And so I tend to be a little wary of at least ducting your intake in my climate. But it is an option if you're somewhere where it's, 50 to 50 plus degrees year round, then you can totally do this and it'll work year round. Um, Now, one thing to be aware of with the unitary systems, they, because they're pulling a lot of air through a relatively fine sort of heat exchanger structure, they do have a filter in them. And that filter needs maintenance. It's not a particularly hard thing to maintain. Usually it's kind of like a mini split filter where it's just this little wire mesh you pull out, you get the dust off of it, maybe you rinse it off in the sink and let it dry out, and then you put it back. You can't do that if your pipes are routed in a way that makes it impossible to remove that filter, which I've seen happen. And if you do that, your unit will not have a very long life, and it's going to drop efficiency really, really quickly. You need to make sure that these are serviceable. Um, we also want to make sure that the exhaust from the heat pump isn't going to blow directly onto a wall behind it. Um, part of that is an airflow consideration, but more importantly, the air coming out of a heat pump exhaust is going to be cold. At least in this case, we're only doing heating. And so the air we exhaust is going to be cold. And if it's right up against a wall, that wall can become a condensing surface as it's chilled by that air coming out of the heat pump. And so you need to pay attention to that. You need to make sure your exhaust at least has enough room to kind of spread out a little bit, isn't just blasting into the wall behind it. Typically, the manufacturer is going to tell you exactly how much space you need around the unit. Um, Again, just little things, but stuff we really do need to pay attention to that might be a little bit new when you're putting a unit in. And on a similar note, if you are ducting your exhaust out, you need to insulate that duct because again, it's cold, and there's a lot of potential for that duct to start sweating. So make sure you're insulated, make sure your filters are accessible, make sure you have enough airflow. Those are really the three. So you can see top left here. This is an example of a unitary system that's had a pipe run over where its filter comes out that didn't leave enough room to actually get the filter out of it. Don't do that. And then on the bottom, you can see one that's in a nice open area. They have their condensate line plumbed. They have a nice drain pan under it. So Cliff's Notes version on the Unitary is that with Unitary systems, it's really, really important for performance, for your end user, and for the health of the system to size your tank correctly. Um, you want to provide sufficient air volumes. You want to install with access to your filters and your serviceable components, and you want to educate your client on how they operate, why they have some slightly different behaviors. Maybe your client needs to modify some of their behaviors, or maybe they don't want to modify some of their behaviors, and you need to do to figure that out as the person selecting equipment. Um, if you do all that stuff right, they'll have hot water. The unit is going to happily chug along in the background for many, many years. Designed lifespan on the unitaries and basically all water heaters is like 10 to 15, sometimes out to 20 years. Um, and the unitary systems are flexible enough that they're good for just about anything as long as you can meet the parameters we've been talking about. Um, which, for new construction, since all new construction is going to be using one, right? You probably are, right? You're designing for this. If you're a designer, um, my suggestion for you is just make sure you have maybe a mechanical space or an area in the garage if they'll let you put it in the garage that's going to have the airflow and the temperature requirements for one of these. Um, in retrofits, which is usually the area where folks are going to have more concerns because we already have a fixed space, the variety of the systems available is going to mean you probably have one out there that is going to work for you and your needs. You might need to run some ducting. Usually that's where the ducting comes in is I only have a closet. I can put louvers in the doors, but what do I do with the extract? Um, and so in that case, you run a duct outside. Problem solved. Space is going to be the biggest issue for a retrofit. And if there's just no shot at getting enough air to the system, that's why split systems are available. You can still have a heat pump based system, just in a different form factor. Um, Suitable install locations, garages, maybe, right? Maybe up here, absolutely. I'm in Washington State. The main thing to watch out for with a garage is the upper operating temperature limit. So every heat pump is going to have a range of temperatures between which they'll work and outside of which they don't. So there's a low end to that, and that's usually what people talk about the most. There's also a high end to that. If you have an uninsulated garage that does get really, really hot, generally the upper operating limit for a heat pump is going to be about 120 degrees. Um, Garages can do that, especially if they're uninsulated, especially if you have like an asphalt roof. It's possible. So you do kind of want to make sure that your garage is going to at least remain colder than maybe 100 degrees. Um, and if it does, I would say the garage is probably the single best place to put a unitary system, assuming your code official will allow you to. It's got air. Usually it's warm enough. Might get too hot, so again, you need to make sure it doesn't. And it doesn't really matter what kind of noise the compressor makes because it's in the garage. It's good. It's a good place. If you're in Southern California, maybe it's less of a good place. There's no tree shading. You get a lot of energy input from the sun, and you can clip those operating temperatures. So you may need to consider alternatives like maybe a laundry room or something like that. Basements, finished or semi-finished, are also great locations. The ground can outcondition anything we make. It might be kind of cold and dank for you, but the water heater is going to love it. Just keep in mind that you do still have condensate, so heat pumps are all going to produce condensate, and you need to manage it. Um, so if you're below grade and you don't have a drain in your floor, you might need to install a condensate pump as well. Um, and that is actually a secondary benefit to them being in a basement. They'll do a little bit of dehumidification, so they're pulling that moisture out of your air. It's not something that I would count on or that I could quantify, but it is going to dehumidify your basement a little bit. And if that's something you want to do, it's an even better location for one of these. Laundry rooms can be nice places for them. Usually they're big enough. People aren't usually too worried about noise in there. Again, that really depends on how big your laundry room is and where it's located. Um, but it also doesn't necessarily matter as much if the exhaust from the heat pump is making that area a little bit colder, which would be a consideration for something a little more adjacent to a living space. Um, and finally, if we can get ducting to the outside and we can get louvers in the doors, we can put them in pretty confined spaces like a closet. Just remember, you do take a little bit of an efficiency hit to that. You have to have a serviceable unit, and um, you need to be aware of the noise. A lot of time, closets are fairly adjacent to living spaces, and so maybe the noise in that case would get kind of annoying for people. So I would do closet would be kind of my last pick, but it could potentially be a decent place. Okay, on to the split systems. So splits come in a couple of different styles now. It's really nice to have more than one thing to say about the splits as that market diversifies a little bit. So again, there's two main ones that I'm going to be talking about, and I am mostly going to be talking about the Senko. That's what most of my firsthand experience is with. Um, but there are two general form factors with these. So one of them is going to be called a monoblock. A monoblock is going to be pre-charged with refrigerant and it's going to be self-contained, right? The refrigerant loop is all within that outdoor unit. And there's no line sets between the heat pump and the tank. We're just running water back and forth. We pull water out of the tank, we heat it up, and we drop it back in the tank. Split systems, or split systems, I still haven't figured out exactly what to call these. Um, are a lot more similar to what you might be useful with like a mini split, where you've got an outdoor unit moving refrigerant along line sets. Um, for a mini split, it would be going to like a coil in a high wall unit or something like that. In water heaters, it's going to a coil inside of the storage tank inside the conditioned space. Splits, the the advantages really are that they don't have most of the challenges we just talked about with the unitary systems. Um, Before I get too far here, again, I just want to reiterate there's only a couple of them out there that I'm aware of, at least that are commonly available. Again, my firsthand experience comes mostly from the Senko, but I have been looking into the ecological lately. It has some really nice numbers. They're nice little units. They solve a lot of the issues that unitary systems have as well. I will do my best to cover both. I'm not an expert on the ecological, um, but at least I get to say that, hey, we now have a couple of split systems out there for you to look at. Um, and so I will highlight some of the cool stuff about the ecological. I'm going to try to refrain from getting too deep into them. Just again, I don't have that much direct experience with them. And with that out of the way, the primary advantages for the split is that it just does not have the limitations that the unitaries do around, well, they do have a space requirement, but if it's outside, that's not an issue at all. And generally, their operating temperatures are going to be a much wider range. So the Sanko 2 is going to go down to about -25 They're heat pump only. They don't have backup elements. And then the ecological is going to run down to about 5 degrees Fahrenheit on heat pump only operation. And then it's going to have some hybrid backup where it'll use those electric elements um, if it gets really, really cold. But realistically, 5 degrees Fahrenheit covers most, if not all, of the US. So we can put either of these outside basically anywhere, right? If you're in Fairbanks or something, you maybe you want a contingency plan, maybe an indoor install, which you can do. But for 80% of us, they'll work pretty much wherever. We do still have airflow requirements. Um, and again, there is a developed and approved indoor implementation for both of these. But generally, we're going to put it outside. And so we just don't run into that space challenge at all. The Senkos are really, really quiet. They are 37 decibels, which is about as loud as the average person whispers. It's not going to drive your neighbor crazy. I've been waiting for these to turn on when I'm out at a job site. I'm also kind of a service tech. And I've been waiting for them to turn on and kind of staring off into the distance and missed it turning on behind me. That's how quiet they are, a couple of feet away. Um, the ecologicals are a little bit louder. They're around 50 decibels. It is on the louder end. Maybe not something to hang on your bedroom wall, but it's not out of the ordinary. And again, the loud thing goes outside. Um, split systems tend to be faster than the unitaries. 20 gallons an hour is comparable to a lot of electric tanks, and that's true for both of these models. The Ecological is claiming up to 33 with their bigger tank. These don't have filters in them, so you don't have a filter to change, but you do want to hose the compressor off once a year or so. There's a pretty minimal maintenance, but you do still need to kind of pay attention to it. And then they're super efficient, right? So COP with these is going to be somewhere between 3 and 5 at normal ambience for most of the West Coast. California, probably high threes, low fours, almost all the time. Both split systems can leverage water temp for storage. And so that's what I was talking about with the load shifting. We store water way hotter than we want to actually use it. So then we can mix it down and basically expand it, if you will, before it gets to the tap. So you end up with a first hour rating that, in the case of the Senko, right, a 40-gallon tank is actually going to deliver 70 gallons if you just open up your hot tap and let it run. The splits do usually have blockout times on them. Again, that is kind of nice if you're in a time of use area where your rates might be higher at peak demand times, but lower, in the middle of the night when everybody's asleep and nobody's using power. You can sort of program them around those time of use rates and only heat your water when electricity is cheap. The split systems are really low draw. The Senko 2 specifically perfect for off-grid projects. It's always heat pump only. We don't have to worry about the load of the backup elements. And they scale pretty nicely, right? If we need more output, we can add a second heat pump. If we need more storage, we can add a second tank. That's specific to the Senko, but it's really, really nice to have where you can get some pretty robust systems with them. And all you kind of have to do is plug in different pieces. Just gonna take a look at questions again. If I put a unitary in a louvered door closet, will pulling air through the louvers add much noise? It depends on how big your louvers are, I guess, but probably not. I mean, it will allow sound from the compressor out a little bit more. So you probably will hear the compressor a little bit more. Um, Depending on where the closet is, that may or may not be that big a deal. I wouldn't put it in a closet that's, in my living room, but down the hall a little ways probably wouldn't be more audible than like a laundry machine. And could cold output air be ducted into an unvented insulated attic? I would be really careful about that, um, mostly from a condensation perspective. Um, it makes me nervous. So I would say you shouldn't. You probably could. Um, I don't have a specific prescription for you, but I would say run it outside and maybe deal with cooling your attic separately. Okay. So split systems do have some challenges. Number one's probably the cost. They do cost more, a fair bit more, right, than even a high-end unitary system. Um, with the Sanko 2 specifically, they're using CO2 as a refrigerant. CO2 needs to operate at 1200 to 1400 psi to work as a refrigerant. If you don't have a frame of reference for that, the tires in your car supporting, 8,000 pounds of metal moving at 80 miles an hour have like 30 to 50 psi in them. 1200 psi is a ridiculous amount of pressure, even by heat pump standards. It's double what a normal heat pump would be using. And that means all the components have to be rated for that kind of sustained pressure on top of the environmental and operational where they're going to see. And so basically everything from the heat pump to the tank is going to be really high quality and bespoke or very close to it, which means you get a really good product, but you do pay more for it. The ecological seems to be going for less than the Senko, still on the higher end of prices for heat pump water heaters, and I would bet installed cost on them is going to be about the same. Um, so I'm going to talk specifically about the Senko for the next little stretch, and then we'll cover kind of what stands out to me about the ecological as potentially a challenge. Um, as I have subtly and tastefully noted here, research can be an issue. I mention this because California, specifically that market, really, really wants research everywhere, everywhere, all the time. I want to research. Um, you can have them, but it has to be one of the either the pressure sensors that knows when your tap opens up, or it needs to be a push button. Uh, do not put a timed or continuous research pump on a Senko 2. It will not work every single time. Your water will be cold and you'll be mad and you will call me, and I'm the person everybody calls when they're mad about stuff, and that's why I feel very strongly about this. Do not put timed or continuous research on Senko 2s. It's a quirk specific to them. It's kind of a weird one. They don't work. Just trust me. Push buttons again are fine. Put them near your fixtures, hit the button. That'll be okay. Don't use motion sensors with them. Um, that is kind of one of those things where people go brush their teeth or they grab stuff out of the bathroom. It happens all the time, and then it ends up being functionally either a timed recirc, yeah, or basically a timed recirc with some extra steps. Um, they do have some pretty specific operating parameters, the Senko 2s specifically. Cover that in a second. Um, but basically, the way you get around all of the weird challenges that arise from the way they work is just by using them right, using them as intended. If you don't expect it to do anything but heat water and it's put in correctly, it'll just sit there and it'll do the thing and you'll forget it exists. Once we start trying to get creative with them, it can work out, it can be cool, but there's some hard limits to what they can do. There's some hard limits to what the manufacturer will say, yes, you can use it for that. Um, but in a normal install, as long as we're not trying to do crazy secondary effects with them, they'll work just fine. For the Senkos, so as we mentioned earlier, those are going to be a monoblock where they're running just pure water from the tank out to the heat pump. Freezing is a consideration. If you live in a cold climate and you lose power, right? I know Monterey doesn't run into that as much, but maybe if you're up in Tahoe or something like that, it's something to consider. It doesn't preclude you installing one. They work actually really, really well in cold climates, but you're going to want a freeze protection measure like heat trace tape is one. They wrap kind of a resistive tape around the water lines, and that heats them back up so they don't freeze. Or they have passive drain valves that are sort of compliant at specific temperatures where the valve will open up. It'll pull in warm water from the tank. It'll heat everything back up so that it's not at risk of freezing. and then they close back down again. Um, that's most of the US, right? Again, California is kind of a funny market where I'm not as worried about the cold climate stuff, but there are still places in California that you need to consider that. And if you're not in California, just about everybody else in the US is going to have to worry about this. I would plan on a freeze protection measure. Not super hard thing to do, not the end of the world, but it does need to be accounted for. If you do experience a freeze with the Senko 2, it's going to be at the water pump, which is pretty easy to replace. It's not awful, but it is annoying. Just avoid that and put some heat trace on it. And then lastly, this is kind of the same as the unitary system, and I was always kind of surprised, specifically with the California market, but this comes up a lot. The space requirement is that the tank does need a place to go. The heat pump does need a place to go. A lot of California properties have been built for on-demand systems, and so it's come up a surprising amount where folks say, "Well, I don't have anywhere to put the water heater," and I go, "Where did you put your last one?" And the last one was an instant water heater, gas powered in a box on the outside of the house. So you do have to plan on having your tank go somewhere. You have to plan on the heat pump going somewhere. I don't know if I would call it a challenge as much as just sort of an operational consideration when you're putting in something with a tank, but do plan on having some space allocated to your tank and the heat pump. So ecological, onto that again. A little bit cheaper than the Senko, but I wouldn't call them cheap. They still are going to take up space, all that good stuff. The big challenge I foresee with them is that instead of a split where, a monoblock where water is going to run between tank and heat pump, they're more like a conventional mini split where we're running refrigerant lines between the tank and the heat pump. The company does offer pre-charged line sets. Um, Anything DIY heat pump, anything with refrigerant gets very dicey and very expensive really, really fast if you do it wrong. Do not DIY this. Mostly for warranty reasons, but also because it will be more expensive to fix than it is to just pay somebody to put it in right the first time. Even with pre-charged lines, I would never encourage you to put one of these in by yourself. Um, Heat pumps with line sets are like the case study for the old adage of never enough money to do it right, always enough to do it twice. Okay, do it once, pay somebody who knows what they're doing. That's really the big one for me with the ecological is just line sets make me kind of nervous because I talk to a lot of DIY people. And then on the professional install side of it, it's this weird regulatory domain middle ground thing where depending on your jurisdiction, usually it's either a plumber or an HVAC professional who is required by the local code officials to put something in. But here we have something where you absolutely want an HVAC person to be doing those line sets, and then you probably have some code requirements around who's allowed to hook pipes up to it. And I can't see it being a cheap install. And I'm not going to run my mouth about it too much. Again, don't have a ton of firsthand experience with the ecological. They're fairly new. I think they're really cool. Just be aware that the install is going to be a lot more complicated and require probably a couple of people relative to something like a Senko or a unitary system. Outside of that, they seem pretty awesome. The split systems are really characterized by flexibility in some directions, right? Again, there are definitely some things they can't do. Think of a fabric that stretches maybe one way and not the other. Modularity, your ambient operating temperatures, simple. Generally, they're simple installs, at least on the Senko side. Again, maybe not so much for the ecological. Um, but they do both have some nice high output water temperature options. The Senko does it by default. The ecological can be programmed for it. And that allows you to do stuff like load shifting, storage, and then in some cases like the Senko, we can mix and match our number of tanks, our number of heat pumps, and we can basically match any demand that a normal residential project would have. Small Planet Supply actually has a commercial division that's a separate company now, but they specialize in heat pump water heating for really large multifamily projects, and they use these same units. Scaling these systems works really, really well, but for a lot of projects, you can basically just drop one in with one heat pump and an appropriately sized tank, and you'll never see the bottom of it. Critically for jobs that have space concerns, right? So this kind of gets back to the louvered door thing. We don't need airflow at the tanks for a split. We just need a way to get the water lines to the tank. We do need a place for the pressure relief valve to go, because that can go off sometimes. And I've had a few calls from folks where they didn't put a pan under their heat or under their tank. The PTR went off, and then there was a bunch of water sitting in a closet forever. So plan on, potentially the pressure relief valve on the tank going off and dropping some water on the floor, pipe it down into a drain pan, and have a place for that water to go. That's about the most strict space requirements that the tanks for a Sanko have. Other than that, if you can connect water lines to them, you're good to go. Um, you can put the smaller tanks just about anywhere, right? And even up to the 80-gallon tank is going to be pretty reasonable about the space it takes up. The 40-gallon Sanko tank, I've seen people put in a coat closet, and then it warms up their coats. If they have copper piping, it'll kind of make the closet warm and act like a coat warmer. I'm not saying that's ideal. I'm not endorsing doing that on purpose, but I have had multiple people tell me that they did it and they like it. Um, the mainly the point about that I'm trying to make here is that we can put the Sanko stuff just about anywhere. The ecological stuff is kind of in a similar boat, where again we don't need that airflow. We just need to make sure we can get our line sets where they need to be and make sure that pressure relief valve is plumbed. Um, the Sankos, you can put your tank about 66 feet away from your heat pump. The ecological is going to be limited around how long your line set can be. That's a totally different class. But they seem to have some pretty reasonable distances as well. I think I saw 30 feet when I was looking at their literature. Another less used but still pretty handy property of the splits is that you can actually put the heat pump inside. They need more air than a unitary system, so it's not that thing where you could put it in a laundry room. I probably wouldn't put it in a laundry room, but like a garage or a basement, all day. That will have plenty of airflow for them. They'll work great. You're temperature controlled in those situations. It's a good place to put them. If you wanted to do an indoor install, which is mostly folks who do live in Fairbanks where it gets to negative 40. But there's an option for you as well. You just have to make sure that you're managing your condensate. Um, the heat pumps on the split systems tend to be a lot more robust than on unitary systems, and they can condense like gallons in a day. So you do need a place for that to go. Um, the Sanko 2 has some really, really limited space heating potential. That's something you hear about them every once in a while. Look into that a lot before you go down that road, before you decide on it, because it is very limited. But it is something that you can do with them. So planning for the splits is pretty simple relative to the unitaries. Again, they're pretty easy to just drop into a retrofit. We really don't need to worry about our temperatures or our airflow at the tank. You need to make sure the heat pump is in a place that's going to get adequate airflow, which usually just means a couple of feet of clearance on the sides. Actually, the Senko, I think you can do up to 6 inches on the back of it. They don't require a whole lot. I would leave a lot more than that because somebody's going to have to work on it eventually. But your space limitation is virtually non-existent here. As long as if you can fit the tank through the door of whatever room it's going to be in, it'll fit in there. Um, the heat pumps can hang up on a wall bracket, like you see here in some of these pictures, or you could put it on a stand. I tend to discourage putting the heat pump directly on the ground. Usually, there's something underneath it that you're going to have to access. In the case of the Sanko, there's a little air bleed valve under it. It's also where the condensate drain is going to drain. Um, so I would plan on putting them up off the ground. And if you're in Tahoe or something like that, be aware of your snow line. If your snow buries your heat pump, it's not going to work anymore. So you might want to put it higher up on your wall. And again, they'll condense a lot. So if you are up in Tahoe, Make sure you aren't leaving a lake of frozen condensate on your walkways, right? And plan on having those freeze protection measures. The heat pump won't really care that it's all that cold, but if you lose power, then you can have that freezing issue. I wouldn't list backup power as a requirement or a planning consideration for a Senko, but if you're going to have it anyway, you're trying to do solar or you're doing like a battery wall and having storage, that basically negates the potential for these freezing because they'll be able to defrost themselves and that heat trace tape is going to be able to kick on. Um, and then, not to beat a dead horse, but again, research, no, don't don't do it. I don't know about the ecological. Maybe they have some different stuff. Senkos, don't put a research on them. And then plan on a disconnect for at least the heat pump. And so if you're not familiar, that's like the little box that hangs on the exterior wall, or potentially in the case of like the ecological on the inside. That's a safety measure for technicians and installers where you can cut the power to the system right there and have a pretty nice visual indicator that no, there's no power going to that. You're not going to zap yourself if you work on it. Um, and running that 230 line and installing the disconnect are going to add a little bit of install cost. So just a heads up, you're going to need um, a 230 line in most cases. The ecological has a 110 option, but generally plan on a 230 circuit and a little bit of electrical work when you're putting these in. So sizing, and I just put the split picture on this, but this is for both of them. These are pretty easy to size. Unitary, especially heat pumps in general, size is now and forever going to be the most important thing for you. They're not as fast as things like gas water heaters, and so with the unitaries particularly, you're going to end up recharging probably 10 to 14 gallons an hour, which is about half of what a normal electric tank is going to do. So they're going to be a little bit slower. We can usually boost that up to a 20 plus gallons an hour. The hybrid systems tend to have something called like turbo mode or boost mode or something that's going to prioritize speed over efficiency. Um, but it is nice to have our system run as efficiently as we can. And so if we go with a larger storage volume than maybe you would for something like an electric tank or a gas tank, um, that's gonna let you charge the tank as efficiently as possible and make sure that you're not gonna run out of hot water. It's also really good for things like rolling blackouts, like load shifting, right? California's energy grid can require a little bit more flexibility sometimes. And so with the unitary system specifically being a little bit slower, having a bigger tank can be kind of a nice thing. Manufacturers will usually recommend the tank based on occupancy. So if you can consult their manuals, they'll usually just tell you, hey, if this is a two-bedroom house with, maybe there's three people in it, you want a 43-gallon Senko tank, right? Something like that. They'll generally tell you what's going to be acceptable for an occupancy. With the unitary systems, generally going to like 120% or maybe 130% of your occupancy and then checking the chart for that entry, right? So if you have maybe four people, but you're expecting to have six people during the holidays or something like that, size it for six people. And that can be good for getting you across that line when you do have a little bit of extra demand. And it also just gives you a little bit of extra storage when you don't. For split systems, that's less of an issue. Usually they're going to have a few tank sizes available. I think the ecological has three, the Senko has three normal domestic tanks, and they will range from medium, either a 43 gallon or a 50 gallon, depending on the manufacturer, up to just enormous, right? There's a 119 gallon Senko tank. I think the biggest one from ecological is 80 something gallons, which are big tanks. The splits are really purpose-built for things like load shifting, thermal storage, and because they're leveraging that high outlet temperature and the use of a mixing valve to make the water safe to use, um, they are really made to have the ability to have a lot of output. Um, So again, 2 to 4 people, you probably would want like a 40 to 50 gallon. If you have large family gatherings or you're just concerned, maybe you live in a 4 bedroom house, but it's just you, um, size it to the house, not what you're currently doing, and get maybe the 80 gallon or something like that. Um, Finally, we're going to bring back our unitary systems and we're going to end with sort of the step one for all projects. So we're going to talk about client expectations and education. I talked about this a little bit in the beginning, where the horror stories that we've all come to know about heat pump water heaters and heat pumps in general all stem from kind of a bad design perspective, a lack of understanding, and I run into this all the time. I get calls from people who are scared, they're upset, they think they need to spend thousands of dollars to fix something that they didn't even know they had, or worse, they just turn something off because they don't know what it does, and then it makes their whole house not work right. Um, and so I would say 90% of the calls that I get from folks who are scared or upset or mad at their water heater, usually they end happily, and generally they only take a little bit of explanation, right? That's the difference between horror story and happy ending, is that you need to let your customer know, hey, you have this. It's a little different than what you're used to, but we know it's going to work great because we designed it right. And you might notice that, for example, if you have a unitary system, you might notice that the area your water heater is in gets a little cold when it runs, makes a little noise when it's on. That's all good. That means it's working right. All you have to do for maintenance is clean that filter out every once in a while, right? That's it. That's what it takes, is just letting people know, hey, this is the technology that's going into your house. This is how it's a little bit different. This is what to watch out for. This is what's normal. And just having that quick conversation with folks about your water heater, but and also all of the new mechanicals. This is something I run into with mini splits and things like that a lot too. Um, it'll help out tremendously. It'll reduce callbacks. It'll improve uh, sort of the perception of your installs, and it'll make people's lives with their equipment better. It's really, really important to talk to your customers when we're putting in heat pump based stuff, even if you think they know it. Um, I have done presentations for architects about things like heat pump water heaters or heat recovery ventilators, assuming that they knew what it was going into it, and they have said, "Wait, hang on a minute, what is this?" So don't assume, just have an upfront conversation about it. And also, it's important to sort of get their personal preferences before you size their equipment or before you select a piece of equipment. And if you're the homeowner and you're looking at something for your own house, these are questions to ask yourself, right? So, are you or is the homeowner really sensitive to noise? Some people are really, really sensitive to noise. Um, that means they're going to be sensitive to mechanical equipment in their space. And some people are like me, where I want a fan running all the time. I kind of like the noise. I've lived in homes with forced air my whole life. I've lived next to train tracks. I had 3 kids. I don't notice anything unless somebody is touching my thermostat. But a lot of people are really sensitive to noise. It's a huge driver, and if they're sensitive, maybe go with a split, or maybe go with a higher end unitary that has a low noise rating, or put it in the garage, but plan for it, right? Don't not ask and then stick it right next to their bedroom and drive them crazy. You also want to talk about, how much water do you guys use? If they're pretty conservative with their showers, there's folks out there who have tiny, tiny, tiny water use every month, and those folks can probably get away with a smaller tank. Generally, those people are going to be a little bit more stationary. They're not going to be moving a whole lot. And so usually they're a little bit safer to size a smaller tank for. But if somebody has 3 kids, or they have like a 200-gallon bathtub, you're probably going to be best off sizing a really big split system that prioritizes your storage system and leverages your water temps. Another thing to consider is some people are trying to build to a performance standard, right? Passive house is notoriously strict. You almost need a Sanko to pass there. But Net Zero and LEED have some different requirements, and you just need to make sure that whatever you're sizing for the project it is going to be considered by whatever certification they're going for, and you need to just make sure that it meets their requirements. And then the big one with clients is, can you or will you modify your behaviors, right? And it's a valid concern on the part of a homeowner. Some folks are ready to go, right? They'll use a tea kettle and a sponge. They'll be the people who use 5 gallons of water a month and save as much energy in water as they can. Most people don't really want to think about their water heater. If your client doesn't want to go press a button that turns the system up when their family visits, consider something that prioritizes the storage and your recovery over time over energy. All right. It'll still be efficient and it's going to end up being more comfortable for them. So we need to personalize a little bit. We need to talk about, hey, this is how this is going to be different for you. And we need to think about where we're putting them in both cases. Even with a split system, you don't want to hang it on a bedroom wall, something like that. And if you do those things, then you're going to set your client up or yourself up with a really successful, nice hot water system. And they're going to end up saving some money on their electricity. And with that, we will end. We'll get to some questions here. Let's see. So we have one that says, if you're worried about the water lines freezing during a power outage, how is the heat tape going to help? What should you actually do? That is an excellent question and something I run into a lot. If your power is out, electric resistance heat trace tape will not do anything. And so what I tend to recommend to people who are in areas, and this is pretty specific to people in areas where you do lose power a lot, and especially you lose power when it's cold. Generally, that's going to be like a mountain region or somewhere that's a little bit more rural. Um, in those areas, there is an option, and that's going to be those thermostatic drain valves that I mentioned. Basically, they're like the thermostat valve in your car, where when ambient temperatures reach about 34, or when the water actually in the line reaches about 34 degrees, there's a little piece of metal that's going to shrink and deform, and it'll allow water to drain out through the valve, and it'll pull water from the tank to that valve, which will then close up. You have a pair of them, so you have one on your intake, and you have one on your or your cold, one on your cold in, one on your hot out, and both of them will open up that way, and that way they'll flush 50-ish degree water through your heat pump and prevent a freeze up, even if you don't have power, because you don't need power. It's just a physical, kind of like a gosh, what do you call them, bimetallic strip. If you're familiar with that, they use those in thermostats on electric water heaters. Actually, it's just a little piece of metal, got like brass on one side, stainless steel on the other, and they'll pop at a certain temperature and make it do the thing. Are the tank flush requirements and schedule different for heat pump water heaters versus traditional? Not really. Most of the heat pumps are going to use glass line tanks with an anode rod. That's still pretty common. Things like the Sanko are going to use a stainless tank that does not have an anode rod in it. Generally, we don't have flush requirements for those. I have seen a couple of cases where maybe somebody's on a well or just in a location that doesn't get a whole lot of filtration and they can see a little bit of sediment building up. But for the most part, the flush schedule is just going to be whatever the manufacturer tells you. And generally for the glass line tanks, it's going to be exactly the same. Um, let's see. Okay, I don't see any more questions. I'll hang out for a little bit. But with that, I think I am
Hey,
about done and I'll turn it over to yourself.
hey, Eric, there's someone asking a question.
Oh,
There, their hand. Javier, if you want to unmute
oh yeah.
yourself, you could go ahead.
Yes, my question was locally in the county of Ventura, we had a city request um, to have a heat pump water heater outside. They wanted a structure to basically enclose the unit.
Mhm.
Do you have any thoughts on that?
Yeah, we run into that every once in a while, and the manufacturers have been pretty good about Like the Sanko and the Ecological are both rated for outdoor installs. Um, so the Sanko is from Australia, where it's very normal to not do anything with your water heater. You put it on the wall outside. A lot of them don't even have roofs over them. I've put a roof over it for sure. But a lot of them are rated to just be outside, and you don't really have to worry about it as long as maybe you've got like a little shed roof over it. For something like a Unitary, those generally are not going to be rated for outdoor installations. But if you build out like a little closet, that's a pretty common detail that I've been seeing in California lately. As long as you have louvered doors on the closet, as long as you've got the airflow that you need, that works great. Especially in that climate, you usually aren't worried about things like the operational floor for temperatures. Um, so the main thing is just making sure you're getting airflow if it's a unitary system that needs airflow. Things like the both of the split systems I've been talking about, you could almost just build a little roof over them and stick the tank outside and they wouldn't care.
All right, thank you.
Yeah.
Awesome. Thank you, Eric. Before I lose some of y'all, I wanted to launch a poll. All feedback is super helpful for us to allow us to bring more trainings into our region. So feel free to give us some feedback on today. And just a little closing remarks. We have our energy code coach. If any of you have any questions regarding energy code, we do have a hotline you could call, or you could submit an inquiry on your project, your question, and our coaches will get back to you. Next slide. Awesome. So if you all have any questions about AIA learning units, feel free to reach out to me. Or also incentives. If any of you have questions about residential incentives, what we have available in the Tri-County area, I am the person. So feel free to reach out. And then coming to you again, the slides and the recording for today, you'll be getting that. And these are some of our upcoming classes that we have. So we hope to see a lot more of you there as well. And with that, like I'll hand it back to Eric. Thank you so much, everyone, and hopefully we can see you again.
Thanks, everybody. Let's see, just make sure we don't have any other questions coming through. And if you would like to reach me, if you had a specific question that maybe we didn't get to, or maybe there wasn't like a decent segue into during the presentation, you can give me a shout at Eric, ERIC, at smallplanetsupply.com. I'll throw that in the comments here.
Awesome. Alrighty, y'all. Have a good rest of your day. Bye.